items we have covered, things you need to know. The biggest thing is to make sure you understand what you got to have memorized and what you don't. You need to know the meanings of what these words are, these symbols in words, and the difference between a logical equivalence, tautology, and contradiction. And usually that's something about explain the significance of this table, or it'll ask you to show why or why not. What you don't need to know is the truth table, the combinations. Those are always going to be given. So I have a problem here from last year's exam, 2017. Usually starting out in words, write down the words, not Q. So this is our Q. So I was not paid. Don't abbreviate. Full sentences. Capital letters, periods. It said write down in symbolic form. So now we're taking and figuring out what this statement was. So if I was paid, so I'm looking back up here and that was Q. Then I completed the task. Completed the task is P. So if then is always an implication statement. So I have if Q, then P. Generally these are going to be if then statements when they have the symbols in there, when they're asking you to put a symbolic notation. And so now they're going to have us compare and see if we can compare these two statements to see if they're logically equivalent, which means that they have the same pattern. And so you notice they already did this for you, basically setting up your table. So these columns are set, negation they did. So now P or not Q. So I'm looking at, so P or not Q would be looking at this column and this column. And or, I always ignore everything else except the combinations. So when I help people with this, I sometimes have them cover up everything that's in between there. So I'm looking at P or Q. I'm looking at true, 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 false with these combinations over here. Be careful that if they go out of order or something, just double check. So or is true as long as one or both is true. So true, look, I'm lining those up, true, false, true. So Q implies P is right here, it's only false when it's true followed by false. Look for the only exceptions in there and you can notice some things. It's only false when it's true followed by false. So we're going from Q to P, so you're really going in this direction. So I'm looking for true followed by false in this direction. True followed by false is false. Everything else would be true. Notice I'm not looking at the words up here, I'm just using the symbols. So they're logically equivalent because they follow the same pattern, trues and falses in the last column. Second question from the 2016 exam. Again, this time we have three propositions, P, Q, and R. Write in words the compound proposition. Okay, so break it down by parts. So I know I have an if, then. That's my arrow here. Q is the teacher is absent. And then this part I can think about separately as P and R. The lesson is canceled and the students are in the library. That's one compound. So if the teacher is absent, then the lesson is canceled and the students are in the library. They're going to give you points for the if then. They're going to give you points for the and for sure. The other point probably comes from having one of the subject in there correctly in the P and the Q part. Okay, next one. Complete the truth table. So not R would be false, true, false, true. Q implies not R. So now again, trying to help you by making a note here. We're comparing Q and not R using the arrow. The implication arrow is only false when it's true followed by false. So there's a false. Hence, justify why Q implies not R is not a tautology, because there's one of the statements is not true. Okay, now we're going to get to some of the really good truth tables. I'm going to do, just for space purposes, I'm going to do this one right here on this page. So I'm going to pause here while okay, so I just added in the P and Q right here. So I have two parts to this. I'm going to first get this beginning part, P or Q. So it's true, 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 false. And then I have not Q intersect not P, and that order doesn't matter there on the intersection. So if you can either do this in your head, or you can just negate everything right here and make a little note. This would be false, false, true, true, and this one would be false, true, false, true. So I'm negating them here, just making a little note, so I can compare them using the and. So that's false, 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 true. So that's one way you can do if you want to break it out into smaller parts. So now I'm comparing this quantity here to this quantity here, again using and. So I'm putting and in here. True and false, false, true and false, false, false. This would be a logical contradiction, all false. Okay, I will make a second video that does the 3 proposition truth tables.